In these examples, what we'll do is use the properties of logs to expand an expression, a logarithmic expression. So basically right now you have log base 4 of a product of three things. That's 64 times x cubed times the square root of y. All right, what we're going to do is expand that out as much as we can. So the first property we'll use is that the log of a product is the sum of the logs. Let me just write that property down here. It'd be log base b of x times y will be log base b of x plus log base b of y. So in that way, I can write this expression as, since I'm multiplying three things together, I'll write it as a sum of three things. So you've got log base 4 of 64 plus log base 4 of x cubed plus log base 4 of the square root of y, except I'm not going to write it like the square root of y. Instead, I will write it with an exponent of a half, which means the same thing as the square root of y. All right, the next thing that I'm going to do is I will use, because I have powers here inside the logarithm, I'm going to use that power, I use the power property that says log base b of, say, x to the r. That could be written as r times log base b of x. Okay, so I'll use this property. First, well, let me come back to this term, okay? This tells you that the exponent 3 can come outside of the log as a factor. So it'll be 3 times log base 4 of x. So basically this exponent 3 pops outside. Plus 1/2 log base 4 of y. All right, now let me deal with this term. Log base 4 of 64, I can actually evaluate that because this comes down to 4 to what power gives me 64. And I know, and I can check on my calculator, that 4 times 4 times 4 gives me 64. So it's 4 to the third power. So therefore, the power is 3. So that this evaluates to 3. So notice what I've done. I wrote this single logarithm, expanded it out to a sum of 3 separate terms. Okay? Let's do that with the next example. Log base a of the cubed root of xy squared over z to the 4th. Okay, so a few things. I actually first want to rewrite this as log base a of, let's say, xy squared over z to the 4th. Instead of thinking of it as a cube root, I'll think of it as the exponent is 1/3. Okay? Now you can put this 1/3 out front first, but I think that's not what I'm going to do. First, I am going to rewrite this as log base a of, and I'll say that this is x to the 1/3, y to the 2 times the third over z to the power 4 times the third. So it can be written like this: x to the 1/3, y to the 2/3 over z to the 4/3. All right, and now what I want to do is expand this out. Notice I've got a product in the numerator. So what I'll do is use that fact that the log of the product is the sum of the logs. And also, since I'm dividing by z to the 4/3, I know that when I divide on the inside, that's like subtracting the logs. So what I'm going to do is I'm going to write this as 3 terms. Log base a of x to the 1/3 plus log base a of y to the 2/3, and then I'll subtract off the log of the denominator. So minus log base a of z to the 4/3. And now what I can do is use that power property that says log of x to some power, you can drop the power out front by multiplying r times the log. So this will give me 1/3 times log base a of x plus 2/3 times log base a of y minus 4/3 log base a of z. And now it's expanded out as far as possible. Let's do the one last example here. This one looks weird because it's like you're looking at scientific notation here, but I can still apply the same properties. Also, I want to notice that like I can kind of simplify the inside here a little bit because this is x to the -2. I can really rewrite that as log of 2.7 times 10 to the 4th times x squared. So when you have a negative exponent, you can like flip the base and then the exponent becomes positive. All right, so I want you to notice that there are 1, 2, 3 factors here. So I can separate this, write it as the sum of 3 separate terms. So this will be the log of 2.7 plus the log of 10 to the 4th plus the log of x squared. All right, now this one I can't really do anything with, log of 2.7, so I'll just leave it as it is, log of 2.7. But this log of 10 to the 4th, remember the log without a base? That really means log base 10. So let me rewrite that over here. I'll do like a side calculation. Log base 10 of 10 to the 4th is asking 10 to what power gives you 10 to the 4th? So the answer to that question is 4. So this evaluates just to 4. Also, you could think of this as like log base 10 of 10 to the 4th, though the log and the exponential kind of undo each other because they're inverses, and you're left with just the number 4. So plus 4. And here, the exponent 2 can come out as a factor. So that'll be plus 2 log of x. So these are examples where you're given like a single logarithm with some expression on the inside, and we can separate, pull it apart, expand it as a sum or difference of logs.